Example 11, we're going to use vectors to find speed and direction. So an airplane travels at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with a negligible wind velocity as shown. So that is this drawing here. What a thing that we need to note that the bearing of 330 degrees corresponds to a direction angle of 120 degrees. So this is the direction angle. And then a really important note to know for these type of problems is in air navigation. Bearings are measured in degrees clockwise from north. So what that means is that this 330 degrees, so this is north, and then so 330 degrees is actually this angle here. Okay, so really important for the next problem when they don't give us the directional angle. So this is 330 degrees, which is the same as 120 degrees. So notice how we will have to solve that a little bit later. Okay, so this is 330 degrees, the navigation of air navigation. So 330 degrees. And then to find that, so a quick way to find that is, or at least one way to find it, is I want to find this angle here. Okay, there's several ways to find it. If I find this angle here, so I notice that the plane or the angle is from here to here, right? So I can let's subtract 270 degrees. So here, 270, and that'll get me this angle here. So 330 minus 270. Minus 270 degrees, that gives me 60 degrees. So this is 60 degrees in blue, then therefore the directional angle here is 120 degrees, right? So that has to equal 180, so it's 180 minus 60 degrees is 120 degrees, which again, they're nice they give it to us here, but they won't give it to us later. The next thing we look at is the airplane encounters a wind with a velocity of 70 miles per hour in the direction of north 45 degrees east. So let's draw that. The wind speed north 45 degrees east. So here's the wind. So 45, here's north, here's east. So therefore the wind is traveling in this direction. So this is 45. The bearing is 45 degrees here. 45 degrees is the bearing. And then the velocity of 70, that is going to be this here, 70. So that'll be our magnitude of the wind velocity. Now we need to find the direction angle. In this case, the direction angle is the exact same thing. The direction angle is from the positive x-axis to that vector. And so it is 45 degrees, which is the same. So now, let's try and break this problem apart more. So we know a little bit more information. So we know that the magnitude is 500, so that's V1. Okay, the magnitude is V1. And then we know theta in this case is 120 degrees. Again, that's our directional angle. Really important to know that. Now we're going to write the vector. V1, remember that is the magnitude of V times cosine theta times I plus the magnitude of V sine of theta, and then that's I and this is J. That's what we're writing. So this is going to be the magnitude is 500 times cosine of 120 degrees I, and then plus 500 sine of 120 degrees I. Then we have V2. So this is V2 here, V2, and we're actually writing it from here, V2. So the magnitude, V2, the magnitude is 70, and then our theta is 45 degrees. Again, direction angle is what this is. So this is going to be 70 cosine of 45 degrees I plus 70 sine of 45 degrees I. So to find the velocity of airplane in the wind, that is going to be V1 plus V2. So we're going to add V1 and V2 together, and that'll get us the velocity of the airplane in the wind. So we're going to add these two together, and so if you convert them to numbers, so 500 cosine of 120, so cosine of 120 degrees, so that was 60. Cosine of 60 degrees is 1/2. And then sine of 120 degrees is root 3 over 2, right? Because I want to simplify this. So let's simplify this. This is going to be 250 plus 250 root 3. And that's I, and I'm sorry, this is I and this is J. Let me write the variables correctly here. Then cosine of 45 degrees, we know that's root 2 over 2, root 2 over 2. So this one simplifies to 35 root 2 I and 35 root 2 J. So we're going to add these velocities, add these together. So we get 250 plus 35 root 2, and that's our horizontal component, our i's together. Then we're going to add our vertical components, so 250 root 3 plus 35 root 2j. And when you add that together, you will get negative 200.5 and 482.5 when you do it all in your calculator. Okay, so we have that. Now we really want to find the magnitude. Okay, so the magnitude of V. So we're given our V1 and V2. And so let's go ahead and solve that. So you just take negative 200.5 squared plus 482.5 squared. And when you plug it all in your calculator, you will get 522.5 miles per hour. So that is the magnitude of the airplane. Well, we're not done though. We have to find the direction, true direction of the airplane. So what we're going to do now is, remember we want to find the angle. So tangent of theta is B over A. And so B we know is 42.5 and A is negative 200.5. So 482.5 over negative 200.5. So that's theta equals tan inverse of that. And what you'll find is that is 67.44 degrees. So again, what that angle represents, 67.44 degrees, that represents this angle here. So in order to find the true direction, how would we find that? Well, we would take 180 degrees minus 67.44 degrees, and then so you get a directional angle of 112.56 degrees. Now, if we want to find the true direction of the airplane, so remember we're looking at air navigation. So this is the directional angle in the pink. And then to find the true direction, we're going to do, so the true direction is from here to here. That's what we want. So one way we can do it is we can do 270 degrees plus the 67.44 degrees. And so that true direction is 337.44 degrees. Okay, so I hope you can see that why I added 270 degrees is because we already know this here, right? So we know that we have to go in this direction, so this is 270 degrees, and we add that 67.44 degrees, therefore that gives us a true direction of 337.44 degrees. So now you're going to repeat example 11 for an airplane traveling at a speed of 450 miles per hour with a bearing of 300 degrees that encounters a wind with a velocity of 40 miles per hour in the direction of north 30 degrees east. So you're going to have to draw two separate planes here. So 300 degrees, that is the true direction of the airplane. So they did not give you the direction angle. So my hint is you need to find the direction angle first, and then draw your vector here with that airplane. Then you draw the wind velocity, and then you will solve it very similar to this. Now, just to give you the answer to this, it's going to take you quite a while to do this. The magnitude is going to be 451.8 miles per hour, and then the true direction of the airplane will be approximately 305.1 degrees. Okay, I'll make another video working through example 11, so that way you can get more practice as needed.